Another recording, and this recording is going to be available for you on the Teams and the campus. So in the short video we learned about how the pulleys were made. Actually now we have pulleys in front of you. At least you got the technology know on how these things were made. They're done by casting. Take a look to the shape and try to inspect it. Just hold the pulleys you have in front of you and try to inspect them. The first thing I'm going to check is going to be the surface we have here. Check the surface. Okay. You hold the part, hold the weight in front of you. What's the difference? Yeah, just say it. What's the difference?
One's the weight, one's the pulley.
The weight. Now, why we have difference in weight? This was made from aluminium. This is a cast iron. The density are different, so the weight is going to be different, so that the volume is almost the same. Now the thing is that the technology of making each is also may differ depending on the application I'm going to make. If I would like to make this block, which is a body of, we call it the gear pump, if I'm going to make this one made of the gray cast iron, it's going to be different than if I'm going to make it from aluminium. We have one of them is aluminium, the one in the front here. This one is made from aluminium. It's going to be lighter, and of course we can do a different casting method depending on the metal I'm going to use. Now, why are we using different metals? What's the reason?
Properties.
The properties. Sometimes it's not about the weight light, it's also about the other properties like the strength of the material we are using. Definitely the pump which made from the iron is going to work at higher pressure than the one which made from aluminium. Because the strength of this material is much higher than the strength of the material we have for the aluminium. Sometimes we have 300, 600 megapascal for meganewton for the steel. Yeah, 600 meganewton for the strength of the material, while we're going to have strength of the material for aluminium 220, so you can see the difference. Okay, so the same thing actually happening everywhere, but we have a problem. Okay, now I'm going to choose a material which is going to have high strength. All the time, the answer is no. If I'm going to make a tank, well, I mean the military tank, I'm going to make it of steel, because this can is going to walk on the ground, need to be heavy. But if I'm going to make an airplane, the skeleton should be light enough. So that's why we're actually using the aluminium as the first thing, and then the nickel on the second thing. But nowadays they start to make something like the composite materials. Well, you know the fiberglass. They use something like the fiberglass to make the whole body of the airplane, like the 787 Dreamliner. Okay, so now different properties. We learned why you choose different materials. Now we're talking about the casting method we have. In general, the casting method is melting the material, put it in the cavity, give it to solidify, take it out. You need to inspect it sometime, do some extra machining on it to take it to the exact shape. The oldest method that they used then was the sand casting. Just make a groove on the floor filled with the molten metal, which actually was the bronze. Solidify, take the part, sharpen it, and use it. Within the time, we start to have the closed mold with the sand. Within the time, actually later, they learned about something called the investment casting. So I use the wax, make the pattern, put the pattern in the sand, mold the wax, and then again to fill the cavity, which is going to be a more complicated shape. I start to have more complicated shape, but still, the investment casting is actually a sand casting, but the pattern now is expandable. I mean, I'm not going to use the same pattern multiple times. I'm going to use it once, then I need to melt it and make it once again. So this is another classification for the expandable casting, where I'm going to sacrifice the mold. Now the pattern is also expandable, because I need to sacrifice it. Within the time in the 20th century, they said, okay, now why we need to do this longer process? Actually, they're still using the investment casting in many of the applications. They start to have something called the foam casting. In the foam expandable casting, the pattern is going to be made of foam. You can make a complicated shape by making these sections of the pattern, glue them together, dump them in the sand, compact the sand, then leave the pattern there. Put the molten metal, all going to be simply evaporated, and the full cavity will be filled with the molten metal, solidified, take it out, and you have the full pot. The good thing with the sand casting is I can use it with super alloys, which is the highest melting temperature. I can use it with the steel, I can use it with the iron, normal iron, I can use it with the aluminum and all the other metals. Simply because the sand itself can absorb any heat and withstand. The problem we have with the sand casting is the quality of the surface are bad. Now you have this block in the front of most of the table or the engine block. Check the surface roughness of this engine block or this block. Just check it by hand. You will see actually it's rough. You do have many sharp edges. Okay, many of the what we call the defects in the casting you can find in the sand casting material in front of you. Simply because this one were made from the permanent mold, permanent pattern in a sand casting process. If they're actually going to spend more money and use the investment casting or the evaporative foam casting, the quality of the part is going to be much better. But they didn't. Why? The cost. Okay, the cost. If I'm going to make it by the normal sand casting, it's going to be much cheaper, and actually I don't like to use the word cheaper, more cost effective than if I'm going to make a long process of making the mold, the pattern out of wax or foam, then I start to do the casting process. The process was fine for long years. Then suddenly they said, okay, now we can do it much better. Actually, if you may don't actually imagine that, but start with making the pastries. They have the mold, they put the paste in, they compress it, add the shape. Okay, now that's why we don't simply make it with the metals. It's a good idea. Now the problem is that the mold should be made of a material that can withstand the heat from the molten metal. So they start to make the mold out of the steel. If I'm going to put the steel inside the steel, simply is going to start to melt it and stuck in it. So they said, okay, now we are going to use it with a lower melting temperature. So they start to make many of the parts using the die casting process, like the aluminium. The aluminium, the copper, the bronze, any other material that have lower melting temperature than the steel mold, this can be casted by the die casting process, or what we call the permanent mold process. If you are going to inspect this part, I think we saw the same part in the metrology now. What's happened is that simply we are going to have the mold. It's going to be closed. We're going to have a cavity inside which looks like this shape. Now we start to inject the molten metal. Later when you come to this table, you will check that there are multiple spots here. We're injecting the molten metal from different points, okay? And those are going to fill the whole cavity. You're going to have no much pressure, too high pressure that we're not going to be able to push the metals in. So we stop, cool it down, because we're going to have water channel within the mold, solidify, take the part. Now, I was pressurizing the metal inside. I will cool it down during a cooling liquid. Result in no shrinkage will happen because I simply injected the molten metal inside. While when I did that with the sand cast iron, like the one we have in front of you, in the sand mold, I was pouring it in. I will rely on the what they call parametric pressure to push the metal inside, of what we call the gravity and the atmospheric pressure, to fill the cavities. The material was not compacted. When it's going to be cooled down, it's going to shrink. And that's what we talked about in the lecture today. We need to have the compensation for the shrinkage by making the pattern a little bit larger. The other thing we have is, because the mold is made of metal, the surface finishing is a grade. I'm not going to say good, it's a grade. Dimensions are accurate. I can take this part from the mold directly and use it. That's not possible actually, that's not for this one. It's not going to be possible for the sand casting process. Now, I would like you to have a look on the parts in front of you. Now, another thing is, I consider that the engineers or engineering students, mechanical, mechatronic, and the electrical engineers, something like recognizing what the material you have in front of you is a part of the IQ for the engineers. Okay, so the people, they have their own IQ about ask question, and they know the common answers. Now for the engineers, they should have the same skill to recognize what the material they have in front of them. Take a look to the parts in front of you, recognize the material, and recognize the casting process based on the specification I just mentioned. You can come here to here later and also now to check these parts if you would like to do. When you take a look to the sand casting part, you'll say, okay, now if it's going to be a pass-surface finishing and it's going to have the non-accurate dimension, we overcome the non-accurate dimension simply by making the expansion for the valve, expansion for the volume of the mold. How to overcome the different dimensions and make it accurate and have good surface finishing? We do an extra process after every casting process, which is a machining to take the dimensions and the surface softness to the required level. Facing here, and we're cutting the channel here. So this channel is always going to have the same dimension for all the tools we are going to make. We are going to make the same height. We can take them down to the same diameter. So it doesn't matter what will be the dimension when we finish the casting. The most important thing that the sequence machine we're going to apply is going to take us to the correct dimension we would like to have. Okay, now how was this part made? Take a look to the device. Yep. Sand casting. And machining because we have flat surface here. For the screw, of course, it was made by casting first as a roll, then they cut it or form it as a screw shape. Alright, so when you open this one, you will find that. Okay, we have a screw inside, which is made first the bar by the casting, then they simply do the machine on it to make it a lead screw. Now, can we make the same part by different processes? Okay. Now, for example, this part, this is very simple shape. This one was made by the sand casting. You can actually see the partnering line on the side here, because we have what the two halves of the mold called the cup and the drag. The cup and the drag. So you can see the partnering line between the cup. This was in the cup, this one was on the drag. When they close it, they pour in the molten metal, they have to open it and take the part. Now this shape is quite simple. So I can simply make it as two halves opening and closed continuously and make it with the die casting, but the material not going to be an iron. It's going to be aluminium, for example. Because we said once again that the iron is not going to be actually resistible to the mold. Actually, the mold itself is going to be expanded due to the high temperature, and we're going to have the accurate dimension for the part. For the spoolie shape, actually, we can do it once again if it's going to be aluminium by the die casting, but it's going to require to do an extra machining on it. In both cases, we're doing machining. The die casted part, I can say, well, generally we say a simplest shape rather than the one we do with the expandable mold. Because we're going to have the mold itself closed, inject the material, open, we need to be able to take it out. So if I'm going to have very complicated shape, like for example the valve. Have you seen the valve? The tap water valve? This one is made by sand casting till today. Mainly it's going to be by the investment casting. If you check the surface of it, you will definitely find out that's made by the casting process. But well, I know that most of the the water taps you have in the indoor is going to have shiny surfaces. What's happened? Why they have shiny surfaces? Go back to last week's module. Sorry? No, actually they just simply add the chromium layer at the top of it. Plating, we talked about this one last week. Okay, go back to last week's module. If you pass it, I don't know, you need to go back and check it once again.
Sorry, I missed the question.
Sorry? I said why the tap water the taps in the room is going to look like a shiny surface, silver looking. Because they were covered, the surface was treated by plating of another material.
Oh, I forgot. It was like the method where you move one part of the metal to the coat the other side.
Exactly. Okay. So no, this was not made by casting. This was made by machining. We used to have this project earlier about the gear pump. Actually, this pump is going to have gears inside. Like, can you carry up this one? Show that to the student. Okay. Now we have this part go inside these cavities, start to rotate, make a negative pressure, and start to pull the hydraulic. Now the thing is that when we ask the student to write down the report, some of the students said, okay, now this shaft can be made by casting. If you're going to make it by casting, pure casting, at the minute you are going to actually start to rotate it, with the torque, it's going to break up like a propeller. So this one actually is a rod. I know the rod is done by the casting, but then we need to do the cutting process for it to have the high strength that can take all the torque and the forces during the operation. Now when we say that we can switch between different operations, if I get to take a look to this shape, to this pump, especially the one in front of you, you will see that we have very complicated cavities inside. Here we have cavities that are connected together inside, okay? And the only way to do that is going to be the sand casting by making the cavities inside using something called the core. The core is going to be a shape that's made of sand. Look like exactly the cavity we have as it goes inside. So we make this one, put it in, we pour the metal, the whole thing will be solidified. When we take it out for the first time, you will see that the core is still there. It's solidified sand, very hard one. The way to take it is, they just simply put a vibrator. This vibrator with the solid but brittle sand, the sand will break up, then we can take it out and have the full cavity. Later, come around, inspect actually with your bare finger the surface we have inside, and you will see actually it was a sand core inside. Just come around and check the whole thing we have here. Before we're going to go further to talk about the changing of the casting processes for the same product. This one was machined actually. There was a core inside, yes? Take a look. Take a look at the shape of the cavity, how the thing is made. This cannot be machined. Okay, it cannot be machined. and it cannot be done by the die casting. The only way to do it is by the sand casting. And also check how complicated the shape is. We'll later explain how this is working, but this is not part of the casting process. This is another example for the pump. This one is made of aluminium, and you can check that actually by carrying the thing. This one's too heavy. This one's too light. But by inspecting the shape and the cavities we have inside and the surface finishing, this one is even more complicated. What is the process has been used to make this part? Take a look to the surface. Take a look at the geometry internally. This was made by the sand casting once again. It's complicated shape, so it must be made by the sand casting. If I'm going to try to make this one as 2 half mold, I'm not going to be able to take all the parts. Now, is it possible to make the core, to use the core and the die casting? We do have cavity, we are going to close it, again to have the cavity inside. Actually, nothing saying no. We can put the core inside the die casting and we can remove it the same way. But the casting process is going to be slower than the mass production of this part, for example. It's very simple shape, close the mold, put the metal in, solidify, take it out and use it. If I'm going to put cores and other details, the process is going to be a little bit slower. If you try to check, usually you keep saying simple, but actually it's not 100% simple. But the simplicity is going to be mainly for the ability of opening the mold and take the part out. This engineering block with this shape cannot be done by the die casting. But if I get to simplify it, simplify the shape, so it's going to be easy to be pulled out of the mold, it can be done by the die casting. Anyone here having the, for example, the small Yamaha motors, the motorcycles? I know what they're using this one anymore. I'm talking about my generation. We did have using that back in the 1999. Just a little bit behind 1999, maybe 20 years before. Anyway, so their engine actually made of aluminium because to make it lighter, I think most of the brass models nowadays are using the aluminium block, which is made by the die casting. This block actually is by Strauss, it's old model. It was American and it's bought by the Australian company. Actually, they keep doing that till 2005. Can you see the photo there? With the lady with the mower? Okay, now this is Guang Hong, Professor Guang Hong. She was one of the professors at the university. She was my supervisor for my PhD. And she was responsible for the technology of the internal combustion engines. The internal combustion engine. And actually she developed these engine blocks. And this photo was from 2000, when they had the Olympic Games. Do you remember when they started to push these mowers around? this was one of the models they had in Sydney Open Park. Okay, so I wasn't here in 2000 actually, but she told me the story. Yep. So if you're going to simplify the shape, then you can simply use it in the die casting. One of the permanent mold casting parts is something. If you're going to search it now on your phone, you will get shocked. Just check about the block of the automatic gearbox. Take a look. Actually, we will shock. We still call it simple. It's made by the die casting process, but actually it's shocking technology. They said they don't have gearboxes in the typical cars. I don't know why, but still, what do you think that the parts made by the casting process in the typical cars? Do we have parts in the typical cars made by casting process?
Sorry, did you say like ball?
What parts in the typical cars made by the casting process?
The frame?
Shout because I cannot hear you. The chassis, yeah, the scan, yeah. What else? The wheels.
Engine block.
The
Engine block, the engine.
well, actually, it doesn't have an engine. It has a motor. It's a typical car.
It's an electric car.
Yeah, but still, the motor actually, the case is made by casting. If you would like to make it from aluminium for better heat transfer, if you are going to make it from plate, this will be also in the mechanical engineering process. The plate actually was a block made by casting in the mill, and then we need to roll it in the formation process. Have the plate, and you can simply shape the plate. But still, many of the parts, like the shafts, the core, the armature of the motor, is made by the casting processes. So, is the casting technology is going to die? The answer is no. And unfortunately, well, it's fortunately and unfortunately at the same time, that this technology is stuck with the manufacturing processes since 6,000 years, and it's going to last for the next 6,000 years. I'm not going to be here, so there's no proof. Okay, so the other thing is, can we replace the casting process by 3D printing? No. Okay, now the 3D printing till today, and I'm sure this is not going to be improved very soon, is just for the rather prototyping or manufacturing very small parts for a very high, well, I cannot say very high position, because I can do the casting for this part in 30 seconds. Oh wait, if I'm going to do that in die casting, I made the mold, I can use it for 100,000 pieces, make this one in 30 seconds and use them directly. And in 3D printed, it's going to have more complicated for the internal cavity of the part. I can even make the enclosed cavity. Yes, but the 3D printing is going to take a long time, number one. Second, the specifications, the dimensions, the surface softness, still for the 3D printing is too poor. Well, actually, we should ask you about printing something in the space, then we can take it back to the metrology lab and check the surface softness for that part. And also, I would like to teach you about how to do 3D scanning for some of the parts and check the accuracy of the manufacturing processes. So far, the casting processes is the best with the terms of the properties, with the terms of the surface roughness behind the machining process. Now the term I mentioned is net parts and near net parts. Net parts is the one that I can use directly without doing any machining. Near net parts, for example, I need to have more accurate dimension for the holes. So I need to re-drill it once again and maybe ream it to have the exact dimension for the part. So minimum steps of the manufacturing, this will be a near net shape. So it's almost ready to be used, but only going to add some steps to make it ready for the application. Now, you can tell that the engine block is made from cast iron by the sand casting, and you can tell that from first check the weight. It's going to tell you the heavy weight is made of iron, mainly it's cast iron. The bad surface finishing is because it's made of the sand casting process. You can see even that the holes are not centered in the middle where it's supposed to be. That's simply because the shrinking happened and this will change the shape of the part. For this part, the gear pump, the body is made from the cast iron. Once again, a great cast iron, and it's made by the sand casting process. When you see this one for the first time, you will see that the holes not going to have the exact dimensions, need to be drilled, bored, and reamed. And the surface need to have face milling. The other side also face milling, and we need to do the internal threading. But it's not going to, you can actually, this is done by the milling operation. So the parts usually not going to be ready to be used after the casting. Is need to go through a sequence of the machining to have them ready for the application. If I would like to change the casting process to make it with the die casting for higher production rate, I need to be sure that the lighter material is going to take lesser pressure. That's in the application of the pump. Just an example. I didn't for the pump. So to do that, actually I need to change the design of the model if I would like to make it with die casting to make it more simpler so it can fit inside the mold. Again, I would like you to check for the internal, this one two-stroke engine block made of the aluminum. You can see that the shape is going to be much simpler than the one we can see in front of us. So the other stuff you must learn about the solidification processes by watching the videos I just uploaded. You can read the slides and again tell you what the advantage and disadvantage of each process. And you can come back to us anytime to ask us a question about how the things are made. Okay, now I think we should stop the recording now and go with the other